For this exercise, we're going to take a look at how to calculate the proceeds, the issue price of a bond. And we're going to go through three different scenarios. And you'll see why it's important for us to understand that the difference in the stated rate of the bond and the market rate will dictate whether the bonds are issued at a discount or premium or issued at par. So let's go with a simple example. So let's say we have the company issues a bond and the face value of the bond is $100,000. And the face value means that's the value on the bonds at maturity. So if a company borrows and issues bonds, at maturity it would have to pay $100,000. And the maturity date is, I am creating this scenario. So the maturity date, so this is when the bonds are all due. It is on June 30th, 2016. Now, the bond has a stated rate. And what a stated rate is essentially the coupon rate, the rate in which this particular bond pays the bondholder. So let's assume that the stated rate of this bond is 6%. Now, stated rate is essentially the amount of cash paid at interest payment date. That's exactly what it is. Now, this bond happens to pay twice a year. So the payment date is June 30th and December 31st. That's the payment date. So it pays twice a year. Now, normally the rate is given to you on an annual basis. That means that on each payment date, let's say June, they will get 3%, which is half of 6, times the $100,000. Now, the bond happens to be, in this example, the bond issue date, or the sale date, happens to be July 1st, 2011. So if I was to draw a timeline, and it's important to do that, this is July 1st, 2011. This is when the bonds were issued. So that's the issue date. But it also happens to be the sale date. In other videos, we're going to show you when the issue date and the sale date are not the same date. So the issue date is really when the bonds, when the company, the borrower, the company issuing the bonds, have issued the bonds in the marketplace. And the sale date happens to be exactly the same date in which the buyer or the lender buys the bond. Okay? Now, this happens to be the maturity date, right? Maturity date would be June 30th, 2016. Which means that there will be an outflow of cash of $100,000, which is the principal. So on this date, the principal will have to be paid. Now, the bonds pay interest every 6 months. So the first 6 months would be December 31st, 11. And the next one would be June 30th, 2012, and so on. Now, if I count the number of years between July 1st, 2011 and 2016, this is a 5 5-year bond. The term of the bond is 5 years. So I just want to compare these two. So that means it's a 5-year bond. Now, how much interest does the bondholder receive? So these are all the interest payment. And of course, the interest paid is governed by the stated rate. So we take 100,000, which is the face value of the bond, times the stated rate. So I'm going to have short form stated rate as SR, and face value is FV. So that means that the bond holder will receive 6% times 1/2, right? Because it's every half year. So they're going to get $3,000. So I want you to imagine these are outflows every 6 months. And how many outflows of 3,000? Well, we're going to have 10 periods. So n equals 10 is really the periods in which we have to calculate the payment of 3,000. So typically with a bond, the principal is paid at maturity, and the interest payments are paid each interest payment date, which in our example, it's twice a year. Now, it could be 4 times a year, or it could be once a year, right? It could be an annual payment, it could be quarterly, it could be monthly. But in our case, in this example, it's twice a year, which means that we have to calculate what the interest paid amount is every 6 months. Now, what's important here is the market rate. And what the market rate does, it dictates the fair value. It dictates the value of this bond. Now, in our first example, and I remember I said originally in the video that we're going to have 3 different scenarios. So let's assume that the market rate happens to be equal to the stated rate. So if the market rate equals the stated rate, so let's put down market rate, okay, happens to be 6%, and the stated rate happens to also be 6%. That is what we call issuing the bonds at par. It means that when we sell these bonds, because the market pays 6, so a typical investor, a lender would look at the market rate and they would say, well, the market pays 6% for any investment, and this bond happens to also pay 6%, then the value of this bond is equal to the face value. So let me prove that to you. So the way we calculate the proceed, the issue price of the bond, there are the following 3 steps. And this is true for all bond issuance. And the issue price is the same thing as the sale price. So this is our first scenario. So we're going to call this scenario A. Okay? So in scenario A, we're going to assume that market rate equals stated rate. So first step is we're going to present value the principal. Because remember, the whole concept here is we're trying to determine what is the value of this cash flow to the investor. And the value of this cash flow is going to have, because these payments happen to be in the future, we have to use present value techniques. So the fact that the principal is 100,000, and we're not going to get that, so the lender is not going to receive the 100,000 until 5 years from now. But because the bond compounds twice a year, we're going to look for the period n equals 10, which is essentially 5 years times 2, but the interest rate, which is always market, you always discount everything at market, and that is at 6% divided by 2, so it's 3%. So what we're looking for is a present value. Now you can obviously use your calculator if you have those special functions in your calculator, but let's use the table. And the table, we need to look for I equals 3. So let me enlarge this table. We're looking for I equals 3 and n equals 10. And we get a present value factor of 0.7441. That's the present value factor. Okay? And that's essentially what your calculator is supposed to do. Okay? Now I'm going to show you how these present value tables work, and there's another video on time value in money. So if you need a quick refresher, you need to look at those time value in money videos to see how the concepts of present value or future value. But so in this case, the factor that we're looking for is 0.7441. Okay, so that's the PV factor. So when I multiply that out, I get 74,410. So what that's saying is this. So in basic concept, it means that the $100,000 is a future payment. And if I was to buy that future payment, it would be worth $74,410. So in other words, if I put $74,410 now, because it earns interest at 6%, it's going to grow to $100,000. So I would be indifferent whether I get $74,410 today or get that on 5 years from now or 10 periods because of the compounding, because interest is earned. Now, the second step is to calculate the interest payment, because we're always looking at it from a liability perspective, right? Because we're the issuer. In this case, the interest payment is the face value times the stated rate. We know the face value is 100,000. The stated rate is 6% times 1/2. Remember, we're going to assume that the stated rate equals the market rate in the example. And the other example we're going to do in scenario B and C is we're going to see how the rates differ, and then we have to calculate what the value of the bonds are. Now, in this case, we know that's 3,000. We calculated that earlier. That's step 2. Step 3 is we're going to present value the interest payment. And because these 3,000 is what we call an annuity means the payment is the same each period, and the timing of the payments are the same for each of these series of 10 payments. So in this case, we can actually use table 2. So we're going to present value the 3,000 times, in this case, we want n equals 10, I equals 3%, which is the market rate, divided by 2. Okay? And they can be found again on the table, but in this case, it's going to be table 2. Now, I'm not going to show you this table when I do the other scenario, so I want you to be familiarized with the time value in money table. Again, take a look at that other video on time value in money. So here's 3% and period 10, and the factor is 8.5302. I hope you can see that. Okay? Now, we're going to use that. So the factor is 8.5302. We're going to multiply that out. We get 25,590. Okay? That when we add these two together, you'll see that the issue price happens to equal the face value. So that is why we call issuing the bond at face value at par when the market rate equals the stated rate. So normally, in a typical bond question, you'll be asked to calculate the issue price, which is what we've done. Okay? And then the second part is usually the journal entry. And the journal entry is easy because that's how much the bond holder will give us, will lend us. So the value of these series of payment is worth $100,000 to them, and that's how much we're selling it to them. So therefore, excluding any bond fee, issuance costs, and any of those other legal costs, let's just exclude that aside because conceivably you would have to pay administration fee. But let's say we exclude it aside. The entry would be debit, cash, that's how much money we're getting, and credit, bonds payable. Okay, so that would be our first entry. Now, we're going to be asked to perhaps do the interest entry, and you'll see in a minute how easy this would be. So for scenario A, the first interest payment entry is going to happen on December 31st, 2011. Okay, and the interest is going to be the issue price of the bond carrying value. So the carrying value, I'm going to call that CV. In this case, the balance owing is $100,000. We're going to multiply by the market rate, 6%, okay, times 1/2 because it's a first interest payment and the bonds were only outstanding for 6 months. That gives us $3,000. In fact, that is equal to the amount that we paid because the market rate's the same. So our entry on December 31st is going to be debit interest expense, credit cash. Now, let's say we asked you again for June 2012, the next payment interest, right? Again, what is the liability? The carrying value doesn't change because we issued the bond at par, right? Times 6%, which is the market rate, times 1/2 again because it's another 6 months, gives us $3,000. And again, the entry is debit interest expense, credit cash. So you can see that when we're issuing bonds at par, it's going to be the same interest entry every 6 months. And of course, at maturity, and the maturity date in this example happens to be June 30th, 2016. We have 2 sets of entry. The first set is the interest payment, right? And we know that that interest payment is the same as any other payment that was made. Okay, so we're going to record that as debit interest expense, credit cash. And we're going to have to principal payment as well, right? And the principal payment is debit, bonds, payable, credit cash. So that's essentially the set of journal entries if you're issuing bonds at face value at par. And the only time that ever happens is when the market rate equals the stated rate. And you'll see that these series of interest payment entries are going to be the same regardless what period we're dealing with. Okay? So you'll see that the same set of entries, and look at the different dates, right? Now let's look at scenario B. Scenario B will be very interesting because we're going to change the market rate. And that's where the fun part comes with bonds. So for scenario B, let's assume that the market rate happens to be 4%. Now, the stated rate never changes. If we think about it, the bonds are normally are contemplated and approved by the board of directors at some point in time. The company realizes it needs to raise money, so it needs to get board approval. It needs to get a whole bunch of other parties involved, legal and of course brokerage firms, to be able to do this. And of course, they will try to guesstimate what the rates will be, the market rate will be in the marketplace. Because technically, when the bonds are issued by companies, they try to predict what the market rates are when they sell these bonds. So obviously, in this scenario, the market rate dropped. So if you think about this, the stated rate does not change at 6%, but the market rate dropped. Now, if you think about it logically, if I was an investor and I'm looking at bonds, this particular company's bonds, if it pays 6% and the market only pays 4%, it would make my bond attractive. Which means that if the market rate is less than the stated rate, then the company, the borrower, is going to want a little bit more money from this bond, more than the $100,000. So that's what we call issuing bonds at a premium. That's what they mean by issuing bond at a premium. So let's calculate what the amount of the premium is. Now, again, we'll go back to the same set of facts, but we're going to also calculate the issue price. Because remember, that was the first step, isn't it? Calculate the issue price. The issue price is the same set of three calculations that we just did earlier. The first set is we need to present value the principal. And so we need to present value the $100,000 times, this time we're looking for n equals 10, because that doesn't change. It's still a 5-year bond. Okay. And the market rate in this case, because we're always using market rate, right, when we present value, it will now be 2%, which is 4 divided by 2, right? So we're looking for that, and again, we're going to use the same table, and you already know how to use the table. The factor is 0.8203, and that will give us 82,030. Second step is calculate the interest payment. And that will always be the same, right? It's always the stated rate. So interest payment equals 100,000 times the stated rate, which is, in this case, 6% times 1/2, which is 3,000. So this step 2 is a calculation that probably you don't need after you do a couple of the bonds because you've already calculated what the payments are. But that's technically what step 2 does. And step 3 then requires us to present value the series of interest payments. So that means that we're going to present value 3,000 times n equals 10, I equals 2%, because remember, it's always market rate. And again, we're going to look at table 2, and that will be 8.9826 to give us 26,948. Now notice I'm rounding. You don't need to round. You round at the end. But from illustration purposes, I'm rounding right now. And the sum of that, and you would expect this, right, to be 108,978, which is higher than the 100,000. You wouldn't expect that because you're going to issue the premium, right? We know that because the market rate is way less than the stated rate. And the amount of the premium is actually the amount, the issue price greater than the face value. So the premium is going to be the 8,978. Now, normally, again, we're going to do the same exercise. It will ask us to calculate the issue price. So let's do that here, the next page. So the journal entry for the issue price. So we're going to debit cash, because remember, we're borrowing, so we're going to get some money from our lenders, right, and that will be the issue price, which is the 108, the amount calculated. Again, I'm rounding here, but please don't round if you're going to do this question. Okay, try to keep it to the 2 decimal places. Now, the credit, there's an interesting part here. The credit, first of all, is to the liability account called bonds payable. The bonds payable is always recorded at face value. So we're always going to show the bonds payable at 100,000 because if you remember in our previous scenario, scenario A, at the last date at bond, when the bond matures, your final entry is going to be debit bonds payable 100,000 credit cash. So we want to show that liability to be 100,000. And we have another account, it's called an adjunct account, and it's called premium on bonds payable. So that is the journal entry at the date of issue. Now, here's what's going to happen. We're going to actually amortize the premium on bonds payable, 8,978, down to 0 as it gets closer to maturity. That's what we're going to do because we want our remaining liability to be 100,000 at the date of maturity. And we're going to amortize the premium every time we pay interest. So every 6 months, we're going to amortize this premium. Now, the method of amortization, there was basically 2 methods. The first method is called the effective interest rate method. So amortization of premium. There are 2 methods. Called effective interest rate method is the first method. And the second method is called straight line, called SL. Now, there's only one method allowed under IFRS, and this is effective interest rate method. This is the only method allowed. This one not allowed by IFRS. Under ASPE, Accounting Standards for Private Enterprise, companies may use straight line which is much simpler, if the interest expense is not going to materially different from the EIM method. So if the financial results of the company is not going to materially significantly change, if we use straight line, then the private enterprise is allowed to use the easier method. And you'll see in a minute why this method is much easier. And I'm going to show you how straight line works, but only for this scenario. Okay, so now that's the first entry, right? Let's do the first interest payment entry. So the first payment interest entry happens to be, so let's do interest entry. So I'm going to do the first one, which is on December 2000. And let me just get the dates right here. 2011, sorry. Okay? So the way I do this, and by the way, I'm going to do two interest payment entry here. I'm going to do one on the next one, which is June 30th, 2012. This is the second journal entry, the second interest payment entry. Okay, so here's what I normally do. When I calculate the interest for the 6 months ending December 31st, I need to figure out my liability from the last time interest was paid. In this case, we've never paid interest, so it would be the issue date. So I always try to calculate the carrying value of the bond from the last time interest is paid. In this case, the carrying value happens to be June 30th, 2011, which is the issue date. And you'll see why. I'm going to show you side by side what happens on the next interest payment date. So in this case, we've got bonds payable. I always like to write this down separately. Add the premium. So I'm going to short form the prem on BP. The premium, as we know, is 8978. So the carrying value is 108978. Okay? We're going to multiply the interest payment with the interest, which is the market rate, and the market rate is 4%, times 1/2, because it's only half a year. The interest expense is 2180. Again, I'm rounding here. So we know under the EIM method, we always calculate the interest expense. So we're going to debit interest expense. I'm going to use red here. Interest expense 2180. That's the number. I know that I need to credit cash. How much? Well, remember we calculated $3,000. That's the cash payment every 6 months. So this one does not change. And to balance this entry, we need to plug. And that plug amount is $820. And that is the debit to premium on bonds payable. That's the amortization. Remember we talked about the fact that 8978, that total premium is going to go down to zero at maturity. That's what I'm doing. I'm amortizing it each period. Okay? So that's our December 31st, 2011 entry. Now, when I'm doing the June 30th, 2012 entry, here's what happens. On this date, when was the last time interest was paid? Well, I already paid the first set. So I'm looking for the carrying value as at December 31st, 2011. And by the way, there's no short form, shortcut way. This is what you got to do. Okay? Now, bonds payable is still $100,000. Now, what is the unamortized premium on bonds payable? We know that it was $8,978, but we've already amortized $820. So now the unamortized premium is $8,158. So now the carrying value is 108,158. You notice that the liability is going down? Of course, it's going down because we want that ending liability to be 100,000. So we're going to multiply this by 4% times 1/2, which is the market rate. The interest expense is 2163. Now, you notice that when you issue bonds at a premium, the interest is declining as it gets closer to maturity. You can see that from this comparison. And you know that the liability is also decreasing. So you'll see that the entry is debit interest expense. So let me do the entry here. This is the entry for June. So debit interest expense, which is the calculated amount, 2163. We're going to credit cash, always 3,000. That doesn't change, so the cash never changes, right? And we're going to debit premium on bonds payable, which is the amortized, and that is 837. So I want you guys to see that the interest expense is decreasing and the liability is decreasing. So a couple of learning objectives here is that if issuing bonds at premium, interest is decreasing as it gets close to maturity, and principal, let's not call it principal, balance owing, probably is a better way. Balance owing is decreasing as it gets close to maturity, and it's decreasing to 100,000. Right? Because we want our final liability to be 100,000. Now, I'm not going to do the next series of interest, but you know what? I'll do one more, and then we'll move on to the third scenario. So the next interest payment date is December 31st, 2012. That's our next interest payment, right? So again, let's calculate the carrying value. What's the balance owing from the last time interest was paid? So the carrying value from the last time interest was paid is June 30th, 2012. Right? So we know that the bonds payable, the liability is 100,000. But what is the premium? The unamortized premium. Well, remember we started with 8,978. We amortized 820, and we amortized 837. So we're going to take 8,978 minus 820 minus 837. Okay, and that is give me 1 second. So that is 8,978 minus 820 minus 837 is 7,321. Times market rate of 4% times 1/2. Gives me 2146.42. Now, remember the interest was 2163, now it went down to 146. So what's our entry? It's going to be debit interest expense, 214,642. Credit cash, 3,000, always 3,000. And the debit premium on BP, bonds payable, is 853.50. This is 48. Okay? That's our June 30th, 2012. So what I've done is I've shown you how the entries are. Now, let's do straight line, because now that we saw that straight line could potentially be used for ASPE. So under the straight line method, so using straight line method to amortize premium, it's really simple. We take the total premium. In our case, it's 8,978 divided by number of periods, which is 10, gives us 897.80. So that is the amount that we're going to amortize the premium. So the way it works is this. So at interest payment date, so let's pick the first interest payment date, what happens to be December 31st. We're going to credit cash 3,000. It's always 3. Doesn't matter which method we're using. It's always the interest payment. The second step that we did to calculate the interest payment, that's always the credit to cash. Now, premium is a credit balance. We want that credit balance, 8,978, to go down to 0. So we're going to debit premium on bonds payable, 897.80. Then that means our interest expense is 2,102.20. So notice what I did here. Under the straight line method, we have to must calculate the amortized premium amount. Must do that first. Because we know the cash amount, this is actually a plug. This is actually a result of balancing this entry. So interest is amount that's only as an outcome. We have to first derive or calculate the amortization of premium. And then the interest expense becomes the result of knowing those two numbers. Whereas when we did the effective interest rate method, we had to calculate the interest expense. And because we know the cash amount, the premium, the amortization of premium, is a derived amount. So here's the difference in the approach here. The effective interest rate method, we have to calculate the interest expense. And then the premium becomes the plug amount, so to speak. Under the straight line method, the interest becomes the plug amount. Now, when we're dealing with an interest payment on December 31st, 2012, or June 30th, 2014. So I'm picking up random numbers here. Why? Because on these dates, interest entry is exactly the same as December 31st, 11. So for 10 periods, the interest entry is the same as above. So this is the interest entry that is going to be the same for any of these periods. So the straight line, the nice part about straight line method, it really simplifies the entire process. Now, let's do one more scenario. And that would be scenario C. We're using the same case facts. Let's assume that the market rate, so remember the stated rate was 6%. Let's assume that the market rate is 8%. Now, think about this. When the company issues the bond, they issued it at 6%. That's a stated rate. That's the rate that they think the market rate will be at the time they sell the bonds. But when they eventually find a buyer, they realize that the market rate is 8. That means that an investor will look for other opportunities, and it pays at 8. So why would I want your bonds? Why would your bonds be attractive? Well, the only way for us to attract this investor to buy our bonds at a lower rate is to issue them at a discount. So we know that if market rate is greater than stated rate, then that means that the bonds are issued at discount, which means that the face value of the bond is going to be greater than the issue price, which is opposite to the premium example. So let's do this example together, and let me show you how a discount works. Now, the steps that we just learned in scenario B is exactly the same in scenario C, but let's go through maybe one or two iterations of this, okay? So to calculate the issue price, we're going to take a look at the present value of the principal, which is 100,000, times n equals 10, I equals the market rate is 8, so it's 8 divided by 4, or 2, sorry, which is 4%. And looking at my time value in money table, that is 0.6756. That gives me 67,560. Now, step 2, we know what that is, right? The interest payment is 100,000 times the stated rate, which is 6% times 1/2 because it's twice a year. Remember, if it's quarterly, it just be divided by 4. If it's monthly, it's divided by 12, right? But obviously, this will be divided by 12 as well. And, right, so we would have more, we have 50 periods, right, if it's monthly. Sorry, it would be, 50 periods. No, it would be 60 periods, sorry, if it's monthly, because it's 5 years times 12. Okay? Now, step 3 would be the present value of the interest payment times n equals 10, I equals 4%. We're going to look at table 2, and that'll give us 8.1109 to give us 24,333. And lo and behold, when you add them, you get 91,893. And you just see that the issue price is going to be less than the fair value. Fair value is 100,000. So how calculate the discount? If this is the issue price, the discount must be the difference between the 91,893 and the 100,000, which in this case is 8,107. So what is the entry? The journal entry is going to be debit cash, it's always the amount that we received. The issue price is 91893. We're going to debit an account called discounts on bonds payable, 8107, and this is a contra account to the bonds payable, so credit bonds payable. So regardless of issuing bonds at a discount, bonds payable is always at par value. It's always recorded at par face value. If you've forgotten that piece, just remember, bonds liability payable, it's always at par. The difference between what you issued it for and what the face value is either going to be a premium or a discount, and that's recorded either as a contra account. In this case, discount is a contra, and premium is an adjunct account. Now, let's calculate the first interest payment just to show you. The first interest payment happens to be, right, June. In this case, it would be December 31st, 2011 is the interest entry. And of course, the first question you asked always is, when was the last time bond was paid? Interest. Well, we never paid interest the first one, so we need to look for the carrying value as of June 2011. So the carrying value for June 2011 happens to be the discount, the amount, the issue price. So let me do that again, 100,000 less discounts on BP. Let me short form that, okay? And that would be 8107, just what we just calculated. So it's 91893. Always market rate, 8% times 1/2. Always market. The only time you ever use stated rate is the actual interest payment, right? That gives us interest of 3676. This is the interest expense. So we're going to debit interest expense, credit cash. It's always 3,000. Remember, it doesn't matter whether we issue bond at a premium or at par. The credit to cash is always 3%, which is the stated rate. And the difference is we're going to credit discounts on bonds payable. We're going to credit because this is a debit balance, isn't it? This is a credit, this is a debit. And we're going to reduce that. We're going to reduce, again, the same concept. We're going to reduce by decreasing the debit. We're going to ensure that our final liability goes up to 100,000. Okay? And of course, that difference is 676. Let's do the next one just to show you what's going on here. The next one is June 30th, 2012. Now, again, ask yourself, when was the last time interest was paid? Well, it was paid in December. So we need to calculate the carrying value as of December 31st, 2011. So bonds payable is 100,000. Now, what is the unamortized discounts on bonds payable? Well, we know it was 8107. Subtract the amortization is 676. That gives us 7431. Again, excuse my rounding here. So carrying value as of that date is 92,568. We're going to multiply that by market rate of 8% times 1/2 again. You'll see that the interest should be going up. It should be higher because now our liability is increasing, isn't it? So our liability is increasing, our interest expense is increasing as well. So our entry is debit interest expense, 3703, credit cash, always the same, 3,000, credit discounts on bonds payable, 703. So, just two more things I want to show you. So when issuing bonds at a discount, what happens? Interest is increasing, is going up as it gets closer to maturity. You can see that the interest expense, the first one is 3676, the second one is 3703. Now notice this is opposite to the premium, right? So interest expense is increasing as it's closer to maturity, and the bonds payable liability is also increasing as it gets closer to maturity, to 100,000. So all doesn't matter whether we're issuing bond at a premium or discount, it all will get to it will all get to the same 100,000. Okay? Now I got one last thing I'm going to show you. So I'm not going to continue on with this one because you can see from the scenario B, we can do the next entry. Okay? But let me show you another concept with bonds. So let's say same scenario, right? So let's say we asked you for, let's say we say there's a face value of 100,000. We have a maturity date of June 30th, 2016. Okay? And the stated rate is 6%. Let's say market rate is 8%. Let's say for argument's sake, 8%, right? Let's say we said the question puts us in the future date. And let's say we asked you to calculate, say the question asked you to calculate the interest, or calculate the interest and provide the journal entry for the, let's see, for December 31st, 2012 interest payment. So that is, let's say we didn't do, so let's say this was the question. Now, if I had that question, what would you do? I would go back, and remember, we calculated the June 2012, we would just do one more, right? We would actually do one more of the amortization to get to the June, to get to December 2012. But let's say we didn't do that. What's another way of determining how to calculate? So let's just make it a little bit more difficult. Let's say make it 2013. So what I would normally do is I would do a timeline. When does the bond mature? June 30th, 16. So this is June 30th, 15. This is June 30th, 14. And this is June 30th, 13. And this is December. This is December. This is December. So they're asking us for this journal entry. That's what they're asking us, right? Now, as I said, I could continue to amortize the bond year over year, but that takes a long time. So the way to do this is to ask the question. If I want to calculate the interest for this period, I want to know what the liability is from the last time interest was paid, which would have been this period. So what I'm trying to calculate is calculate the carrying value as at 6/30/13. That's what I want. Right? That's what I want. So really, for me to do the December 31st entry, I need to calculate one period back, because that's the carrying value. That's the liability that I need to calculate the interest expense. Now, how many periods is that? You got 1, 2, 3, 4, 5, 6. So now I'm going to redo the issue price using n equals 6. So I'm going to present value 100,000 times n equals 6, I equals 4%. So if I look at I equals 4%, so let me make this bigger. Okay, so I equals 4%, n equals 6. It should be 0.7903. So that is 79030 plus present value of 3,000 times n equals 6, I equals 4%. This is table 2. So table 2 is an annuity. I equals 4, sorry. N equals 6. That would be 5 point, oh my gosh, this is so small. Give me 1 second. 5 point, what is it? 2421. Yeah, these tables tend to be very small. Get 15,726.30. Add that to the 79,030. It's 94,756.30. It wouldn't surprise me that it's going up, of course, right? Because again, as I said, the liability should be increasing. Then we're going to multiply this by the market rate of 4%. That's 3790.25. So my interest entry on December 31st, 2013, interest entry is debit interest expense 3790. $25, credit cash 3,000, and credit discounts on bonds payable 790.25. So you could see that by showing you this really neat trick, shortcut, I call them shortcut, is if we were to ask you a interest payment entry on some random future date. So in this question, it just happens, I just happen to pick 2013. The first, what I would do is I would do a timeline, count the number of periods to maturity from the last time interest was paid. So that's what you're trying to do, is calculate the carrying value of the period before that interest payment date, which happens to be June. So you count the number of periods, redo the present value calculation, because the technique with present value is you should be able to find what the liability is at any given point in time on that timeline. By doing that, you're able to calculate the carrying value of June 30th. So this is now the carrying value of June 30th multiplied by the market rate of 4%. That's the interest payment for this period, for period 1. And that's what you're trying to calculate. Okay? Thank you.